Go.
Hello, everyone. Welcome to Practical GCP. In today's session, I would like to talk about BigQuery atomic operations. So in this session, we'll cover, first of all, to start with a common mistake in data ingestion or transformation that when using BigQuery and the operations are not atomic. So we'll start with that. And then we'll describe what is a atomic operation. So after we describe the mistake that can be made, what problem it can cause, then we'll start talking about what is the atomic operation and the two mostly used BigQuery atomic operations and why these are very important to consider using instead in your design. So to start with, I've prepared this diagram, which is a common mistake that is usually made on doing data ingestion or transformations. So assume this table A is like a table you're temporarily creating that has some landing area or some data that you get from an upstream system, or this is a upstream table that you need to do some transformation on by running some SQL and to put into another table. So you start with table A, which is this place. Then you would like to produce table B, right? So both of these are on BigQuery. The common mistake is typically when the process is designed to run this in two separate steps. So the first step is to look at, let's say, if this table B is partitioned. So the operation might be looking at a specific partition, truncate that partition first, right? And then load the data into the partition. So this design has a huge problem. So imagine in the cases of, there's some issues, right? There's some issues with this data. And then for some reason, it's not compatible with the table B schema, right? Or if there are some bad data that you couldn't load the data into table B. So what could happen is that operation would have failed, right? If you run it straight away directly into table B, that operation would have failed. But because you've truncated table B already, the stakeholder will be wondering, what is going on here? There's no data in table B, right? So at that stage, you're actually stuck because the previous version of the data you already truncated, so you don't have it anymore. So this would then become an operational issue. And then, what would typically happen is someone will have to urgently fix it, and the stakeholders can't even access yesterday's data or anything kind of before that, right? So in a lot of these scenarios, when you truncate the data in place, right, just because you think this is a lot easier to do, to just get rid of the data and then load it in. Oh, it's a very easy operation. But in fact, when this happens, due to issues from upstream systems, and the stakeholder would not be able to get access to data that previously was there, right? So out-of-date data in a lot of use cases is better than you don't have anything at all, especially for reporting, right? So people still can look at the last quarter or last year, or whatever that is, right? And then when you want to reproduce this, you could end up getting rid of all of that data because of you trying to do this first. That process might only take a few seconds if everything works correctly. But when designing systems, you must think, what if there is a problem? In this case, the problem is table B is truncated, right? You could truncate partitions, you could truncate the whole table, and then when that happens, the stakeholder would not have any data left. So this is the common mistake I've seen in many places, and then that is going to cause a lot of problems. So I've mentioned the word atomic. So I'd like to talk a little bit more about that. So if you look at this Wikipedia page, if you search for computer science acid, so ACID, it's typically a thing that is being used in, a set of properties in database transactions intended to guarantee like data validity, discover errors or power failures, all sorts of other things. But the one I would like to focus on here atomicity. Because basically it's also called atomic. So these two words are used interchangeably. So to put this in simple word, what it means is, let's say you run an operation, right? One operation, you try to achieve a task. In this particular case, is you try to get rid of some data in the target table and you want to load a new version into it, right? So that could be because of logic change, could be because there's issues in the data, whatever. Atomic basically means that operation must happen in a single unit. So you can't have in a situation that half of the things have happened, right? So truncate is only half of the operation. Load is the second half of the operation. So the important thing is this too must happen in a single unit. In other words, if you can't do the second part, let's say if you can't load the data, the whole operation must fail, right? So it cannot truncate the data either. So this has a huge benefit because let's say if you run a SQL, you try to truncate the data, but you know that the second part is not going to work if you do these two at the same time. Then the previous version, right, the out-of-date data, either that's a previous hour or previous day, would not be touched, right? This is really important. So assume this is in an operational scenario, then the previous version, because it hasn't been touched, then the urgency of fixing it is not actually that great, right? So the stakeholder is not even aware you have a problem that you try to load the data and it didn't work. Because okay, in that case, you get an alert, you go ahead and fix it, you make sure it works, and then everyone's happy, right? So this is really, really important. So now let's focus on two specific use cases of BigQuery atomic operations. So the first one, these two are very commonly used, by the way. The first one is write truncate. This basically means you do exactly the same thing like what it was before, but in BigQuery, there is a way to do it in one atomic step, right? You're still starting from table A, you run a SQL query, and then you do these two, the truncate, right? The truncate first, and then write at the same time as one atomic operation. So if you look at this documentation, it's called a write disposition configuration. So this is the Python SDK, but if you use the command line, the gcloud command, the BQ gcloud command, or Java SDK or whatever SDK, it's the same concept. It's called the write disposition. So there's three of them. Write append is basically just append more data into existing tables. It doesn't touch the existing one, but in this particular case, we're looking at write truncate, right? Write empty is where table must be empty. Then when you write the data into it, it will check if the table is empty. If it's not empty, then it will leave. The query would fail, right? Write truncate is the table, whether it exists or not, it doesn't really care. It go ahead and truncate that table or the partition in the table, and then it will put the data, the new version of the data into the target table. And this will happen in one atomic operation. You can see here is also mentioned is as one atomic update in the completion, right? So this is the first one. The second one is called the merge. The merge statement is something I've covered in a previous session in the practical GCP videos, right? The merge statement, as you can see here, it will do the when, the match, the comparison between the source and target tables. It's a lot more complex. It's a lot more sophisticated on the things you can do. It's not just limited to you have to truncate the table, but you can compare based on different conditions and only remove certain part of the data or update certain part of the data, right? And then this is another atomic operation that you can make use of, right? So just to summarize, so the mistake commonly made is truncating the target, which will cause problem to the stakeholders, making everyone's operational life a bit of a nightmare because the urgency of fixing a problem is great, right? To truncate the table and then load. So this is a common mistake. So as an alternative, you would either want to use the write truncate, which is truncating the target table or the target partition, then right into the target table in one atomic operation, right? Or you would utilize the merge statement if you need a lot more granular control of the comparison between the source and the target table, then you apply the merge, right? So these are the two use cases. So I think hopefully that's very useful for when you design systems to consider and understand why the atomic operations in BigQuery is very, very important. Okay, that's the end of the session. Thank you very much for watching. See you next time.
Go out!